how are likelihood and probability related? Think about this question during the lesson. Each spin of a spinner is an action that has an unknown outcome or result. The action spin the spinner at the right has 4 possible outcomes: yellow, green, blue, or red. An event is a set of 0 or more outcomes. How likely is each event? Spinning yellow, spinning green or blue, spinning a primary color, red, yellow, or blue, spinning purple, spinning red, yellow, green, or blue. Each section is the same size. There is 1 section of each color. The spinner has 4 sections. Each section is shaded 1 of 4 colors. One section is yellow. Spinning yellow is unlikely but not impossible. Half the spinner is either blue or green. Spinning blue or green is neither likely nor unlikely. How likely is spinning a primary color, red, yellow, or blue?
Select your answer.
Three of the sections are primary colors. Spinning a primary color is likely to happen. There is no purple on the spinner. Spinning purple is impossible. The whole spinner is blue, red, yellow, and green. Spinning one of those colors is certain to happen.
Describe the likelihood of the spinner landing on an even number. Explain.
The likelihood of spinning an even number, if you look at the chart, the spinner, the even numbers are 16, 12, and 14. There's 3, and then there's 11, 15, and 13, which are odd numbers. So that's half and half, 3 and 3 of this spinner. So half of the spinner is the odds, half is even. So it's neither likely or unlikely that you'll get an even number.
Mr. Garcia has a jar containing 10 marbles on his desk. At the end of class, each student draws a marble from the jar without looking, notes its color, and then puts the marble back in the jar. If a student draws the red marble, the student does not have to do that day's homework. What is the sample space?
A sample space, S, is the set of all possible outcomes for an event. Since there are 10 marbles, there are 10 elements in the sample space. This is one way to represent the sample space. S, again, represents the sample space is equal to the quantity of R, standing for the red marble, G, 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 standing for the 3 green marbles, and P, 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 P for the 6 purple marbles. And that's how you can identify your sample space.
Mr. Garcia decides that too many students are drawing the red marble. He adds 10 yellow marbles to the jar. What is the new sample space?
Instead of writing the entire sample space over again, I'm just going to add to that sample space. And for the yellow marbles, there were 10. So you would add to that quantity that was in the example, Y, 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 Y. Yes, all 10 Ys to stand for the yellow. And again, you would just be adding that to the sample space from the example.
Elena rolls a number cube with sides labeled 1 to 6. Part A. What is the sample space for rolling the number cube?
Sample space would be 1, 2, 3, 4, 5, 6. Those are the options when you are rolling the dice. What is likely the likelihood that you will roll a 2? What is the probability of rolling a 2? So probability of an event is the ratio of the desired outcome, rolling a 2, to the total number of possible outcomes. One of the 6 sides has the number 2, so rolling a 2 is not likely but not impossible. The probability of rolling a 2 is 1 out of 6. This can be written as 1/6 is approximately 0 and 167 thousandths, or about 16 and 7/10%. Is it likely that Elena will roll a number less than 7? What is the probability of rolling a number less than 7? All 6 numbers on the cube are less than 7. So all 6 of the outcomes make up this event. It is certain that Elena will roll a number less than 7. The probability of this event is 6 out of 6. This can be written as 6 out of 6 equals 1, or 100%. Is it likely that Elena will roll a number greater than 6? What is the probability of rolling a number greater than 6? None of the numbers on the cube are greater than 6, so this event is impossible. The probability of the event is 0 out of 6, or 0%.
The game piece shown has 12 sides labeled 1 to 12. Part A. What is the sample space for rolling the game piece?
So the sample space for rolling the game piece would look like S for sample space, and then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. That will be your sample space.
Part B. What is the probability of rolling an 11?
So the probability of rolling an 11, there's only one 11, so there would be 1/6 of a possibility. If you wanted to find the percentage, just so you do the long division, you divide the denominator into the numerator. Add a 0. 6 goes into 10 once. That's 6. That's 4. Add a 0. 6 goes into 4 5 times. 6 times. And that's going to be 36. That's 4 again. If we add another 0, it will give me again a 6. So the percentage, if I move my decimal to the right 2 times, that'll give me 16.6, approximately 16 and 6/10% of a probability. So that will be what you would have as a percent. Okay.
Part C. What is the probability of rolling a number greater than 5?
So greater than 5, let's see, we have 6, 7, 8, 9, 10, 11, and then 12. That's 1, 2, 3, 4, 5, 6, 7 numbers that are greater out of 12. So we would write that as 7/12. And again, if you wanted to write it as a percent, you would do long division to find your percent. Add a decimal. 12 goes into 70. 5 times. That's 60. That's 10. add another 0. That 12 times 8 is 96. That's going to be 4. Add a 0. It's 40. So it can go in 0 times. I'm sorry, not 0 times. Goodness. 3 times. That's 36. That gives me 4 again, so it's going to repeat. But all I want is a percent. So I'm going to move that decimal over 2 times to the right. So now my percent is 50, about, let's say 58%. So now 7/12 is my probability. If I wrote it as percent, it'll be about 58%.
Part D. What is the likelihood of rolling a number greater than 12?
The likelihood of rolling a number greater than 12 is impossible because there is no number greater than 12 on this dice. So that is simply impossible.